And now we're back, this time in Australia. You can see the Opera House in the background. I thought this was a nice backdrop for you. So I'm going to go ahead, now that you had a look at how the mechanics look for calculating the t-value for a dependent samples t-test, I'm going to give you the equation. So it should look a little more familiar to you now that we've looked at the last segment for you. Again, I'm going to try to deal with my straight lines. This go round, I'm going to show you some variables and we're going to infer what they mean. So I'm going to put a D up here. Now, if you think back to the previous screen that we showed, what do you think D stands for? Well, there was a word that occurred twice in the columns, and the word was difference, okay? If you see me put a bar over something, what do you think that means? What do you think that stands for? Where else have you seen this? Well, you're probably thinking, rightly, about X bar. That just means you took the mean of the row of X or the column of X. It's the same thing here. D bar just means you took the mean of the D column. You can think back to what we were saying, and we'll see it again in a moment. So basically, for the numerator, to find the calculated value of the dependent samples t-test, you're going to take the mean of the difference column. And again, we'll do all this, so it's nothing to get too worked up about. For the denominator, you're going to see some familiar characters. Okay. First of all, square root. So you absolutely cannot forget to do that. Okay. The next part, we have another fraction because it seems like that's what we do with t-tests. Okay. See if you recognize this one. Oh, yes. There you go. Sigma d squared. Now think back to the last slide or the last segment that I showed you. Wasn't there a column called difference squared? Well, you already know what the sigma means. It means add it all up. Okay. Now let's take a look at what we have here. Okay. There is a little bit of what can be confusing to the eye here, but it won't be for your eyes. Okay. We just need to take it slowly. Okay. Part of the equation here for this is, again, it's another sigma d. Go nice and slow. Okay. It's supposed to be a parentheses. There you go. So there is a big difference here, and we must get our heads around this now, because when we enter the world of correlations next week, it's going to come back. So we might as well just get our heads around it now. Look at these two variables here, this one and this one. Can you tell me the difference between these two? Because they look awfully similar, but this is where students really, I think, need to slow down. And there's a little bit of a way to say it. This is sigma d squared. This is sigma d, pause, squared. See if you can spot the difference here. Sigma d squared, sigma d squared. So they're not the same thing. This has its own column. This has its own column as well. It just happens to get squared later, but they're not the same value, and you're going to see this. It's going to be pretty clear to you after we run through an example. Now let's go ahead and take a look here at this one then. The denominator for this fraction, n. This is the first time we've seen this too. N, okay, minus 1. Okay, and we're just going to close off the parentheses. So that's the whole fraction. Again, if you notice here, there's not very many parts. They're just in different kind of they're just kind of in different orders and in different configurations. Like you see D 1, 2, 3 times, but it's D in 3 different kind of configurations. Here it's the sum of D squared. Here it's the sum of D squared. And then here it is D bar, okay? D bar would be the sum of the difference, okay? I know that if you're looking at this, you're kind of maybe going, oh my gosh, you know, what's this all about? It's not much harder than anything else really we've done. And then you can, because you can also see, like, for example, in is going to occur in 3 spots. 1, 2, 3. It's actually not too hard. Again, you just have to slow down. So we're going to slow down and we're going to go take a look at an example and plug in all of these numbers. And I think what you're going to find is that you are going to be better at this than you thought. So now before you, what I've prepared is a chart that I have filled out with material from an example in your book. This is near the end of the chapter, and it has to do with self-assertiveness training. And this is on page 102 for reference. But you can see the way I've constructed this is a lot like I explained earlier. This looks a tremendous amount like the process we went through to find standard deviation in chapter 4. Now, if I'm going to explain this a little bit further, let's take a closer look. We have a population. It's a common population, so it's one population of people. All of these people have a characteristic in common. They want to increase their self-assertiveness, and to do that, they're going to go through some kind of a training. Now, they were randomly assigned to either a group that received just the literature for self-assertiveness, or they went through the full training program, which I expect was in person. And then at the end, they were asked to rate on a scale of 1 to 10 how effective their self-assertiveness training was. So you can see, if I break this down slowly, that the first pairing of people, you found that the person who went through just the literature only rated it as a 4 in terms of effectiveness, whereas the corresponding person who went through the training program rated it at a 6. And so that's the way you would read this particular pairing. Now, same thing down here. This pairing of people, again, from a common population but randomly assigned. Okay, the person who gave the literature evaluation gave it a 5. The person who went through the training program gave it an 8. So you can kind of see that the numbers are a little bit higher over here, but still we don't know whether or not there was a statistical difference unless we go through the math. Now, because I started already talking about the difference, let's go ahead and talk about the null hypothesis. I prepared one for you. It's a little wordy, but maybe we'll just forget about that for now. Okay, the null hypothesis that I constructed this is there is no significant difference between the average effectiveness for literature-based and in-person self-assertiveness training. A little wordy, but hopefully it captures the essence. Now, what else can you say about this chart in front of you? Well, you already know one of the variables. You know that there's pairs of participants. It's the equal number of pairs in each sample. So there's the same number of participants in the literature as there are in the training program. Okay, 15. So at the very bottom, I have the ultimate score. So I went ahead and put n equals 15 down here for you. So we're going to go ahead and now take a look at how this plays out mechanically. Now, for the purposes of time, I'm going to go ahead and provide for you the answers to each of these, each of the variables below. And the most important thing here is that you understand how I got them. That's more than anything else the most important thing. So you can see that just like with standard deviation, we go across. And so the person in the literature camp gave it a 4. Person who's corresponding gave it a 6. The difference between these scores is -2 because 4 minus 6 is -2. Then when we square it, it's going to be a +4. Same thing here. 5 minus 8 is a -3. We square that, it's going to be a 9, okay, and so on and so forth. Then, if you look at the columns, you see at the bottom, you can see there's going to be a lot of negatives here. That's fine. It doesn't really matter. You can see that if we total them all up, I'll go ahead and just tell you what the answer is. I've done this probably 3 or 4 times just to make sure the answer was 100% correct. It's going to be -45, okay, -45. That's going to be the sum of D. So in this particular case, D, there you go. D is going to be the sum of D, or sigma D is -45. Okay. Then we have D bar. Well, I already told you earlier in this presentation that anything that has a bar over it is likely asking you for the average. So in order to find the average here, we're going to have to divide the total sum. Okay, so we added these all up, -45, divide it by the total number, which is 15. So there you go. So if we divide sigma D by n, we're going to get this. I'm just going to give it to you. It's going to be -3. Okay. So now, when we go to the next column and the final column here, we see that the difference squared, okay, again, you know how we found that. Okay, -2 squared is +4, -3 is +9, -4 squared, 16, so on and so forth. You got it. When I added all of these up, because see how it says sigma d squared? Okay, sigma d squared. Okay, I guess I could have done this too for you as well. Let me show you how to do this. This is kind of fun. Okay, go here. Okay, go like this. Okay, and then if you're looking to put the exponent up there, you just choose this guy right here. Okay, there, now you go. I'll turn that off for you. Just a little skill for you. If we add up all of this, sigma d squared, this is the d squared column, this is what you're going to find. It's 167. I've already done the math multiple times, so don't have to worry about that too much. Okay, let's go down to our scoreboard. Okay, we already know that n is 15. We know that sigma d, what is sigma d? Okay, -45. Okay, -45. Okay, we know that sigma d squared right there, okay, is 167. And we know that d bar is -3. And remember how I said earlier when we were looking at the equation, there's really only a handful of variables to consider. We already have them here. There they are, okay? There's not much work left. You just have to plug these into the equation and do the math, and that's it. Now, granted, you have to actually do it. I mean, it takes a minute to do that. But at the same time, it's not so hard to figure out where all these numbers came from. I showed you how up here. So now what we're going to do is we're going to go ahead and transfer these total numbers over to another screen, and then I'm going to show you how to complete the computation. Now we've returned to the whiteboard, so I can actually go ahead and show you how this looks, plugging in all the numbers. What I've done is I provided you with the equation right here and the scoreboard, as I called it, from the previous section, with all the highlighted numbers, the d bar, the sigma d squared, the sigma d, and the n. So again, these four are the only numbers we're really plugging in. It's just a matter of where. So let's go ahead and do that. So we see from our generic equation that d bar is the numerator. So we'll just take d bar. There it is, -3. We'll put d bar right here. If I can keep my line straight, that would be a good thing. Okay. We can see that sigma d squared goes here. So we'll just say sigma d squared right there. Okay. Again, it takes a steady hand. Okay. Not our great 7, but whatever. Okay, then let's take a look at how this equation reads, because this is where it gets a little tricky for students, okay? All right, so we already know the n is going to be 15, okay? There you go. Steady hand. Okay, now this is where it gets troubling for folks. Remember, when we say sigma d, squared, it's not the same as sigma d squared. So we're going to go ahead and in parentheses put, okay, sigma d, which is right here, okay, -40, tight space right here, 45, squared. Okay. There we go. Okay, that's a 2. And then we have 15 times 15 minus 1. There you go. I'm speeding up a little bit, huh? Am I getting a little faster at these drawings? I hope so. I'm not Solomon Khan. I can't go as fast as he can, but I admire him. Okay, so now if we start to do some of the computations and make all this math palpable, we'll go ahead and go like this. Okay, we'll keep the numerator the same since that's the last thing we're going to do. Okay, -3. Okay, now here's where we get to kind of get a little more. And the other thing I absolutely do not want to forget here, because students forget it all the time, is that we still have a square root to deal with, okay? There we go. Okay, we'll keep the 167 the same. Okay. And here's how this goes, okay? Now, -45 times -45, okay? Obviously, when you multiply a negative times itself, it's going to be a positive. In this particular case, I'll just go ahead and show you just so you can follow along if you're doing it at home. I'll pull up my calculator. Okay, and we'll go like this, 45, and mine you have to hit the 45 first and then hit negative. okay, times itself is 2025. So we'll go like this, 2025. Okay, there we go. So now we're going to divide that by 15, okay, ultimately, okay? But for now, we'll just go ahead and set up the equation so it looks right. Okay, now at the bottom here, 15, this is of course the denominator for this fraction. Okay, 15 times 15 minus 1, that's just going to be of course 15 times 14. Whoops, 14. There we go. All right. So to give you a little more space and to make this a little more centered, I'm going to come down here now. Okay, so we'll go ahead and say this, okay, because we're getting there, people. Okay, again, we'll get, the hardest part of this whole thing is getting a straight line. It really is. Okay, -3. Okay, don't forget the square root, please. Please don't forget that. Don't let me make you forget the square root. Okay, so this will be the same, 167. Okay, minus, okay. Well, let's go ahead and just take care of that denominator really quickly. Let's just go like this. Clear that out, and we'll say 15 times 14, just to get that out of the way so we don't have to keep worrying about it. Okay, 210. All right, so we'll make sure this is 210 below here. There we go. Okay, now if we go up here, we go 2025 divided by 15. And I seem to have lost my calculator. Here it is. Here it is. Okay, 2025, okay, divided by 15. What are we going to find? Ah, 135. Smaller than you thought, huh? Okay. There we go. Now these look like manageable numbers, don't they? I mean, you know, we've gone from this to this, and it was fairly short. It wasn't that long of a time we took to get from here to here. Okay, it really is not that bad. So then we go over here, okay, because again, we're trying to follow PEMDAS as much as we can. Please excuse my dear Aunt Sally, or whatever you have for that one, okay? All right, so again, please do not forget that square root. It doesn't matter how many times I say it. I can't probably say it enough because it's what most students forget the most of. Okay, so we're going to go ahead and do this now. I always seem to X out of my calculator. All right, let's try this. Let's move the calculator over here for a second. And we're going to start with this set right here. 167 minus 135 equals, okay, 32. Okay, that wasn't so bad, was it? 32. All right, so we got that. I'm going to go ahead and put that up there. 32. Okay, divided by 210. There you go. Hey, the zeros are getting a little more clear, don't you think? Took me a while on this one. Okay, so pulling back up that calculator. Okay, I guess I should just learn to knock it down to the toolbar. Okay, 32 divided by 210. It's going to be a small number, isn't it? Because 32 divided 210 times is a small number, right? Let's try that. Oh yeah, it is. Look at that. So we have 0.15. We'll just take it out to 2 decimals like I usually have you do. 0.15. Okay. Okay. 0.15. Okay. And the numerator, -3. Okay, we're getting it down to a manageable number now, huh? What do you think? Okay, I think we have enough space down here, don't we? Yeah, we do. Okay, still haven't learned to knock that calculator down to the toolbar. Okay, so now what we want to do is go 15, because we're trying to take, I'm sorry, that's not what we meant to do. 0.15, okay, square root, aha. So it's going to be 0.39, isn't it? 0.39 once I took the square root of 0.15. So again, rounding, okay, so that 7 turns that 8 into a 9, okay? Toolbar, okay. All right, so it's going to be -3 divided by, because we took the square root, we're done with that. Okay, 3, 9. Whoops. How about we make that delineated? How about that? See, you're learning all kinds of things today about like how to use a whiteboard on computer. Okay, so I cleaned that up for you enough. Okay, we'll go back to black ink. There we are. Okay, there we go. Okay, so what is this -3 divided by 0.39? Okay, so let's go ahead and clear that out, and we're going to go 3, I make it negative, divided by 0.39, and this is going to give us our ultimate answer. Okay, -7.69, -7.69. So I'm going to go ahead and X out because I can do that now. Okay, so it's going to be -7.69. Okay, so that is going to be, as we notate it in this way. Okay, here's the t calculated. Okay, equals -7 point. Whoa, goodness gracious! You'd think I'd learned this stuff by now, but no. Okay, sorry about that. Sorry. Apologies all around. Okay, let's try that again. Point. That'd be a big 6, wouldn't it? There we go. 6, 9. Okay, so that's going to be our calculated t value. Now, do we care that it's got a negative there? Here, I'll put it here. No, we don't care that it's negative. For comparison purposes with the calculated and critical t value, we don't care that it's negative. Okay, that's part of the uniqueness of a t-test analysis. Now I'll get this cleaned up and move us back to the Sydney Opera House, and we'll have a pretty background to kind of take us home on all of this. And so now that we've gone through all the calculations to find the calculated t-value, I've gone ahead and cleaned up the screen for you, although it's really hard for me to block the Sydney Opera House. I hate blocking it with this screen. It's so beautiful, but nonetheless, we're going to keep going forward. And so I've gone ahead on this board and put up the t calculated value, which we found in the previous section to be -7.69. And again, do we care that it's negative? No, we don't. Now the next question, how do we find the t critical value? Well, if you've been with me long enough, and you certainly have, you know that any any critical value is going to require a certain equation, okay, the df, okay, df, degrees of freedom, to find. Now, for the degrees of freedom for a two-sample dependent t-test, the equation looks like this: n minus 2. Okay, n minus 2. So in this particular case, we remember that the n was 15. So it's going to be 15 minus 2. Okay, which gives us a df 13. So there you go. So we'll just go ahead and sum it up. Okay, I'll give it a capital because why not? df. It's actually easier to write the capital than the lowercase d in this format. Okay, df equals 13. So what do I do with this? Well, you already know. I go to a chart. Where's this chart at, Professor? It's on page 93 and 94 of our text, which you again already knew because you've used it in previous lectures. Okay, so if we go to page 93, and we put our finger on the df, and we move all the way down to the 13, and then we move across, we're going to find that under the 0.05 column, that the t-value here for that particular significance level is 2.160. Why do they have to put the 0 in there? I have no idea. Why do they do that? They don't really need to, but we'll do it because they do it. Okay, 2.160. Okay. All right, so you're only left with one question. Okay, which one's greater? And again, you cannot get fooled because if we're dealing with t-test, we're looking at absolute values. Is the absolute value of -7.69, okay, greater than or less than 2.160, and we already know what's greater, okay? This one is, okay? Why? Because we're looking at the absolute value. We don't care that there's a negative there, okay? So what are we going to do? We're going to reject, okay? Reject, okay? In this particular case, we'll say the H0, H, okay, 0. And the only other thing I can ask you, so first of all, let's ask what that means. Okay, reject the null hypothesis. The null hypothesis was there is no significant difference between the averages for effectiveness training being either literature-based or in person. Well, it turns out if we reject it, there is a difference. There's a significant difference, and we saw that the numbers for the in-person training were higher. So there is a difference. More people rated more highly the in-person training than the literature. If we ran this whole test 100 times, we'd find something similar. So the only thing left to ask then is about this p-value, okay? I've been asking you this the last couple of weeks, the p-value, all right? How does the p-value play out in this particular case? If we know that the calculated value is greater than the critical value, what can we say about the p-value? Well, we can say that the p-value in this case, okay, is what? P-value is, it's got to be equal to or under 0.05. So P is less than or equal to 0.05. That's the only way it could be, okay? So I hope this made sense. I went hopefully at a pace that's not too fast. I always worry that I'm taking way too much time. But nonetheless, I hope that helped you a little bit here. And if you have any questions, you can certainly send me an email, set up a conference to do office hours, whatever you need, you know that. People have called, that's fine, it's really not a problem. Okay, so just to be absolutely conclusive about this whole thing, there should be down here, there should be a little screen momentarily that says, take the quiz. And if you tap take the quiz, it's going to ask you about 4 questions. And that will conclude today's lecture, and you'll get the attendance score. Okay, again, I stress again, the attendance score is not going to count toward your final grade. It is simply my ability to take attendance for this class. That's all. So please don't stress if you got 0 or 100%. It's a matter of watching this. Please take the quiz, and I will see you on the next lecture.